I am Benoy Joseph, Faculty of Social Science, Silver Hills Higher Secondary School. Today we are going to discuss a chapter from 9th Standard Geography. It's about the signature of time. Now from the word itself we can see the time which is being signatured, different things when we are talking about the entire world in a whole. Now here we are going to study about how the movements happened in Earth, what are the contribution of structure of Earth interior in this movement, types of movement happens in the Earth's interior, and the result of this movement that we are going to explain here today. Now before that itself, I will go through a small activity for you people. Let us see the world map. Here we can see some dotted lines near to the continental edges. Here we can see the red dots which are pinpointing the zones of severe earthquakes, earthquake prone areas. Now we can observe the next slide. It's the same world map where we can see red dots. We can see red dots which demarcating volcanic zones. Different red zones near to Pacific and even all over the world, especially in the Pacific Ocean ridges, where in the borders of ocean we can see the volcanic eruptions. The first one was the earthquake and the second one is the volcanic eruptions. Let us see the next one. Here we can see the shaded part which depicted the mountains, the mountain ranges, where we can see the wide variety of mountains. We can see everywhere the mountains and other things, but especially there are certain places like in above India, we can see this entire area being covered with mountains where the Everest being located, and the highest peak of our country, the Mount K2. Each and everywhere we can see the shaded portion, it's demarcated the mountain ranges. Now we will go through the first one, the earthquakes. The second one, the volcanic zone. And the third one, the major mountain ranges. Now we will plot these three maps, incorporating with these all information in one map itself, one world map itself. We will just put the volcanoes, mountains, earthquake in the same world map. What we can observe here, it might be depicted like this. You can see all the mountains, all the volcanic zones and the earthquakes are resembling one another. We can see majority of these all things happening in the Pacific ring. We can make it as a ring itself, in the Pacific ring. And we can see some similarities all over the world. Now what might be the conclusion of these all? Earthquakes are comparatively frequent in certain places. The second point, volcanoes are more common in certain specific areas. Earthquakes are specific in certain regions. There are some peculiarity in distribution of mountains. Now when we are talking about mountains, there are some peculiarities incorporated with the volcanic eruption and even the earthquakes. Now the last one, according to me, earthquake zones are distributed near to mountain zones, and the volcano also been residing in these phenomena. That is why we had to go through deeper version of what is actually the structure of earth. Now when we are talking about the structure of earth, it's been divided, broadly divided into three: crust, mantle and core. That we already studied. Like an egg, we can peel it off. Then we can see the first one, it's the shell. Then the next part, we can call it as the white part, it's membrane. And we having a yolk and the nucleus. Likewise, the earth also having its own structure. The first one, we called it as the crust, then the mantle and the core. Now what is the importance of this thing? The crust together, it's been broken in pieces like eggshell. It's a small pieces and the big pieces. According to this, there are been divided pieces of earth into different plates. We are dividing the earth lithosphere, we call it as the lithosphere, into small pieces. One we called it as the big pieces, another one we call it as the less or smaller pieces. The first one we called it as the larger plates, and other one we called it as the minor plates. Let us see. There are major plates and minor plates like African plate, Antarctican plate, Eurasian plate, Indo-Australian plate, North American plate, Pacific plate, South American plate, etc. and etc. And here we can see certain minor plates also, that is Somalian plate, Nasic plate, Philippine plate, Caribbean plate, Arabian plate, likewise. These small pieces of landmass, the lithosphere and the larger piece composed of what we called it as the plates. Now we can see here, before this plate movement and other things, there is a scientist called Alfred Wegener. Before these all plate margin and other things, we are going to discuss about Alfred Wegener. He was a scientist. He put forward a unique theory called it as tectonic movements of plates, or he called it as plate tectonics theory. According to him, in the beginning, around 200 million years before, there was only one continent. According to him, it's around 225 million years ago, there is only one continent, called it as Pangaea. And the only one ocean, called it as Pandalasa. According to him, there was only one continent. There was one continent, called it as Pangaea, and the ocean called it as Panthalassa. After many years, because of the rotation of the earth and other things, it's been splitted towards two. One we called it as the Laurasia in the northern hemisphere, and in the southern hemisphere, the Gondwana land. And after the rotation of the earth and other seismic activities, according to Wegener, this area being shifted into two. In the northern hemisphere, it is the Laurasia, and in the southern hemisphere, Gondwana land. Again afterwards, it's been splitted into, now we can see the 7 continents. It's according to Alfred Wegener. He gave some theories and facts related to this thing. Now when we move towards this from African continent, the edge of Africa and the Indian continent can be easily puzzled down. He called it as the jigsaw puzzle. And when we are getting together all the continents in one shape itself, it's been like jigsaw puzzle. We can easily inter-exchange with these things. Now the second fact he gave, when we are comparing to the plate boundaries, for example, in India, we can see elephant. The same elephant, there are some minute changes in their shape and size and even the physical features, but it's elephant itself. They have been resembled with Africa. There are certain other things like coconut. We can see coconut palms. We can see the coconut palms in Africa. There are places like West Indies and other place, and the same thing here in Kerala. There are some fossil remains. We can resemble it with the different continents. According to these all, he proved that it's been the continents are moving apart. This is all about Wagner's hypothesis. But many of the people are not believing it. And afterwards, there was a theory incorporated with these all theories being put forward, called it as plate tectonics theory. Now, according to plate tectonics theory, the moving of landmass, that is lithosphere plate, under which the asthenosphere, a jelly type material, because of the convectional process happened inside the earth, it moves the plates from one another. The movements are different. The movements, either it will be opposite side, it will be adjoining or to the closing or coming together. Let us see which are the major movements happening in the Earth's crust. The first movement we can observe is divergent, moving apart. For example, there are two plate margins. If something happened in the beneath of Earth's interior, due to this, these movements happened, it will move apart. These two plates move apart. This movement we called it as divergent movement. Because of the movement inside the earth, if the plates are moving apart, we called it as divergent movement. The second movement is the convergent movement. If anything happened inside the earth, if two plates, A plate and the B plate, if move towards each other, we called it as convergent margin. Now the third movement is it slide past one another. The A continent and the B continent slide past each other. The A movement of the plates and the B movement of the plates, it will just slide down. This we called it as the movement of the plates. Now here we can see what are the important formation caused by these movements. One, if it is moving apart, divergent, it will create seafloor spreading, and if it is coming near to this, it will create fold mountains. And if it is sliding past each other, it will create volcanic eruption and other contingencies. Himalaya is an excellent example for converging plate margin, Himalayas. Now, when we are talking about divergent, Mid-Atlantic ridge is an excellent example for divergent movement. Now, ring of fire in Pacific Ocean is an excellent example for shear margin or transformation of margins. Thank you.